Hello, you're welcome to this lesson. In this video, you're going to solve this question I have on the screen. The question says, in the pulley system shown, the effort P is moving downward at 6 meters per second and increasing at 3 meters per second squared. Determine the speed and acceleration of the load W. So let's look at how we are going to solve this question. So for this question, the figure that will be given to you will be figure A. You will have to draw figure B yourself. So to draw figure B, you have to just draw figure A. Then when you are done, you label it as it has been shown in figure B here. So to solve this question, the first thing you have to do is to draw a datum. Okay, so to do this, you have to draw a straight line. You have to draw a straight line, okay, through the first two pulleys. Okay, the line has to pass through their center. So this becomes my datum. So after drawing the datum, what you have to do is that to determine the length of the part of the rope, so you have to measure from that datum to the end of the rope as in for this part. Okay, so to measure SA, you have to measure from where the datum is to the end of the rope here. Okay, that'll give you the SA. And then in some cases too, you have to measure from the datum to the center of the pulley, like what I have for SB. Okay, so this is the center of the pulley. Okay, and then SB was measured from the datum to the center of this pulley. Okay, so those are the two ways to determine the length of the ropes which has been tied around the pulleys. Okay, so that's how it is done. So in this case, you see that you have SA, which is from the datum to where the effort was applied, and then we have SB, which is from the datum to the center of the pulley B. So to solve this question, you have to generate an equation that relates SA and SB. Okay, so let's look at how we are going to do this. So we are going to write an equation that will be equal to the total length of the rope or cord connecting the pulleys. Okay, so the first part of the rope that I have is SA, right, which is from where the effort is applied, which is from this point here to this point here, that is SA. Okay, that's also part of the rope. And then we have another part which is SB. But when you look at SB, we're going to have more than one, right? Let's take a look at that. I'm going to have the first one to be from the center of this pulley here at the top here to the center of pulley B. Okay, that's from the center of pulley C to that of pulley B. That'll be our first SB. And then you're going to have another one here. You're going to have another SB here. And then you have another SB here. So you see that we have three of the length SB. Okay, and then we have one of length SA. So let's look at what you are going to do. So you're going to have plus 3SB, right? Because when you add all this, that's when you're going to get the total length of the rope or the cord. So this will be the first equation that you will get. So now we are going to use this equation to find the speed and acceleration of the load W. So to find the speed, we'll have to differentiate this first equation. And when I differentiate this, I'm going to have VA plus 3VB equals 0. I got 0 here because the length of the rope is constant. So when you differentiate the constants, we get 0. This becomes equation 2. So we are going to use this equation to find the velocity of the load. So let's look at what you are going to do. So you see that the effort is wrapped around pulley A. Okay, so what that means is that pulley A will have the same velocity as the effort, and then the load is also hanged on pulley B. So that also means that the load will have the same velocity as pulley B. So let's take note of that. So we are going to have you're going to have this to be VB, and then you're going to have VA here, right? So to find VB, then we will have to make VB the subject. So you're going to have 3VB equals minus VA. So making the VB stand alone, you have to cancel out the 3 here. So you're going to have VB to be equal to minus VA over 3. But before we continue, we are going to have some sign. We are going to define the positive direction and then the negative direction. Okay, so that we will know how to explain our answers. So what we do here is that we consider the downward motion to be negative and then the upward motion to be positive. Okay, so after doing this, when we get our answer and it is positive, you know that the load will be moving upwards, and then when it is negative, you know that the load will also be moving downward in that case. So the velocity of pulley A has been given to be 6 meters per second. So you know that VA equals 6 meters per second, but it is moving downward, so you will have to negate it. So let me write this again. That will be minus 6 meters per second. So let's substitute that into the equation we have. So I'm going to have minus 6 divided by 3. When you do this, you're going to get 2 meters per second, and it is positive, so that means that the load will be moving upwards. So what this means is that when the pulley A is moving in this direction, or when the effort is pulled downward, let me put it that way. When the effort is pulled downward, okay, the load here will be moving upward, because we said the downward direction is negative and then the upward direction is what? Positive. So that's what that means. So let's answer the second part. We say we should find the acceleration of the load W. So we're going to use equation 2. So we will have VA plus 3VB equals 0. So when you differentiate this equation with respect to time, you're going to get the equation for acceleration. So you're going to have AA plus 3AB equals 0. I want to find acceleration of the load, so that means you will have to make AB the subject. So you're going to have AB to be equal to minus AA over 3, right? And then since the velocity of A is negative, its acceleration will also be negative because it is moving downward. So we're going to have the acceleration to be negative, and it is given to be 3 meters per second squared. So we're going to have minus 3 divided by 3, and then this will be equal to 1 meters per second squared. So this